unmute Anshul, which is the second participant, if that is fine.
Hello, am I audible?
Yes, perfect, yes. Perfect.
All right. Hi, Graham.
Hi, Anju.
Hi. So, okay. So how should we go about it? Is it like?
So I'm just we're just sharing your project now on the screen.
Okay.
Just give us a minute's time.
Sure. Sure.
So Anshul, you can see your project, right?
Yeah, I can see my project. So you would be navigating as I would be speaking, or
yes, I'll be navigating as you're speaking, and you can start now. So you've got around 10 minutes to present it.
All right. Thanks, Rikan. So I'll just start off right away with the background of the problem that I tried to solve, or the kind of the problem statement. So basically, I was looking for the data set in which it's a kind of something new and interesting. So one data set that I found on the it's on the Kaggle website, was about the PUBG game. So the game was primarily, it's a multiplayer game in which there are like a lot of people come together. Specifically, at max 100 people come together and they battle to win the #1 position. So there is a lot of data around it in terms of the number of the kills a player makes, the amount of distance a player, the player travels on foot, by swimming or by driving, the number of revives he has, and there are like a lot of data that is present on the PUBG official API. So the goal of the problem statement was to identify if a player is playing a game. So can we predict if the player would be amongst the top 10 people that would be participating in the game? So the the target variable was that to identify if the person would be in the top 10 or not. So that was the introduction. So coming to the data fields, so Vikram just can scroll, yeah. So there were a list of little like above.
Okay.
To the data part. So yeah, so it lists all the data fields that are there. So just having a glance on the data fields, you can have an idea about what are the data that you're looking at. In terms of the, so basically I looked at the number of number of players that are killed. There are number of headshot kills the player makes. What is the number of revives? How many times the player has been revived in a game, and walk distance and all of that. So we can just scroll up. So these are the couple of libraries that were used. Those are the standard ones. So you can scroll, yeah.
Just tell me when to stop. Yeah.
Sure. You can stop here. So just having a glance about the data in terms of the number of rows and the field and the type of the data fields were there. I kind of explored what the data looked like. So the data had a lot of IDs, which were like group IDs, match IDs, the person IDs, and there were other data points in terms of the what kind of data structure the data has. Is it an integer, it's a double value, or a character value? So just having a glance, I could make out that these IDs won't be of much value in the prediction scenario. Whereas there are a couple of data variables like the number of kills that might be helpful, or the the number of time the person is healed, that might be helpful in predicting if the person will make it to the top 10 or not. And there are a couple of more ones like winning points and the number of vehicles destroyed and all that. So there was there is a variable specifically called win player percentage. So what is the probability of a person winning? That was in the range of 0.5 till 1. zero means zero, like he will not win the game. One means that he is the number one player in the game. So basically, the target variable was derived from this data, from this specific data variable in terms of calculate. You can scroll up a little bit. So the target variable is top 10 is derived from this one in terms of checking out the probability which are greater than 0.9. So I have segmented that data in terms of 0.9 above are counted as true and below that are false. So my target variable is top 10. You can scroll up, Vikram, a little. So yeah, just stop here. So I'm just trying to glance over the distribution of the target variable in my data set. And I found out that mostly they were false data. I mean, mostly the data set was around false. So out of 2 lakh records, more than 1,50,000, approximately 1.6 lakhs were false, and the remaining were in the true. You can scroll up. Yeah. So these were the basic the glance of the data set. Then I came to the variable analysis. You can stop there. So this is an interesting part that I found out. So I kind of summarized the number of kills in a match, whatever the summarized the number of kills, and I found out that there were a minimum of 0 killings and the maximum of 48, which means that a player can make a minimum of 0 kill, and at max, out of 100 player, a single player can kill 48 people. And then there was a summary of walk distance, which means that the player has minimum 0 meters traveled and a maximum of 13,530 meters he would travel. And similarly, there were other variable analysis in terms of weapons acquired. You can scroll a little, Vikram, if you. Yeah. So you just scroll up. So yeah. So these were the observation I made while summarizing that. So, so broadly, I got an idea that most number of kills were 48 and minimum was 0. And a player acquires a maximum of 72 weapons in a game match. And a match duration ranges from a 2.5 minutes till 37 minutes. So that was the idea about the game summary that I got from the basic observation. Then came the data wrangling part, which talked about the cleaning the data in terms of identifying how can we make the variables as factor variables. You can scroll up. So these were the values of the different variables. I found out there were a couple of variables like kills and headshot kills, which can be converted to a factor variable. So these were done as I converted those into the factor variables. So you can just scroll up a little. I'm just hunting up in terms of time. Yeah.
Yeah, sure.
So, so these are the identifier. I just as mentioned, like group IDs, match IDs. Those were not relevant to me in terms of predicting. So I need to filter out those kind of data variables from the data set. So initially, I could identify these IDs. You can scroll up. Then there were helper function to identify the unique values. Those need to be filtered out as well. You can scroll up. Then there was, I found out if there is in the target variable, if there is any record which has a missing target variable, I need to filter out that record from the whole data set because that target variable value is not present with me. So that I filtered out. And then there was, you can scroll up. So these are all the helper function which kind of help me filtering out the exact variable that I wanted. So, okay, then you can scroll up. You can stop there, yeah. So, and then there came a point I need to find out a correlation between the numeric variables. You can scroll up a little, because I just need, yeah, fine. So as you can see, there are a strong correlation between number of groups and the maximum place, the winning point and the rank point. So I kind of filter out those variables which had a strong correlation. So those were number of groups, the winning points and the rank points. Those are also filtered out from the data set. You can scroll up here. All right. So moving on, exactly. You can scroll up. So yeah, then there came the important information point. So this kind of variable gave me the importance of each variable after filtering out whatever data set I had. And I found out that walk distance and the killing place constitute the most importance, like how much distance the player has walked in the game and what is the position of the player when he kills a person. So those are my most important variable that I need to take into account. You can scroll up, Vikram. So okay, so these were data in terms of exploration, which gives me an idea that most of the people die without making any killings. As you can see from the bar graph, there are zero killings and the maximum count is there. So most of the people die without killing anybody. You can scroll up. Uh, So this graph is basically depicting if the person will win the game, essentially will be in the top 10 or not. And I could find out that if a player is within, if the player killing range is between 6 to 8 players, then he has a higher probability of winning the or coming in the top 10. You can scroll up. So then I made a bar chart to explore what are the type of games a player plays. So player can play in a solo match, in a dual match, or a group of four, a group of two people. And I found out that the highest one was in the solo one. You can, if you slide down, right. So the bar chart shows the maximum at the solo first player. So it means that most people want to play solo. So that was the idea that I got from the data set. Yeah, you can go on. So I mean, so this chart gives, you can, if you scroll right. So in a normal solo match, you can see a spike, which means there's a uniform distribution. So this is a graph between a match type and the number of kills. So in a normal solo match, the killing is the maximum. As you can see, there's a uniform distribution. So that was just an idea about what is the distribution between the type of match and the killing. You can make sure, yeah. And this is a bar chart which boost is nothing but boost are something like medicines you take when you are injured. So the number of boost is equal to like 0, 1, 2, 3 up till 21. So the more number of boost you use, the higher chances you have in winning. So that was the overall picture that I got. Then came the part of modeling. So there was a training data set, like a 70%, 30-30 distribution among that. You can scroll up, Vikram. Yeah. And so this was the, you can stop there. So this is an interesting plot, the bar, what do you call, the Rplot plot, which gives me an idea that if the walk distance, the amount of person, if he walks in a game, it is, if it is, what do you call, greater than 1825, and the killing place is less than 25. So we essentially come to the node number 7. And then we make a distance that if the walk distance is even more, that it is greater than 2713. So this guy has a probability of coming in top 10 with the 40% chances. And then also if the killing place, if it is less than, if it is, what do you call, less than 6.5, then the player has a winning chance of 27%. So you can scroll up a little. So again, as we had hypothesized, like there was a hypothesis of ours in terms of the variable importance. The same is given by this model in terms like highest. The most important part is the walk distance, how much how much distance the person has walked, and the killing place in the game. So that's what I mentioned. The walk distance has the greatest impact in deciding if the player would be in top 10 or not. So then there was an evaluation part. So these are all the functions that are written. You can just scroll up. I'll just directly jump onto the matrix. Yeah, you can stop here. So the training data set had a, what do you call, the area under the curve at 87.6%. So you can scroll up. The validation had 87.8%. That means that it's something on the similar, like we are on the same track. It's nothing off part. And then the testing data set that came, which was also around 87.9. Which means that the model that we have, the kind of model that we did, it is not overfitting, neither underfitting. So it's kind of something on the similar, what we had predicted. It's accurate. So the conclusion that I made was the most important feature which help in predicting the player would be in top 10 or not is the walking distance and killing place in the game. And if the player walks a distance of more than 2600 meters and has a killing place less than 6, he has a better chance of making it the top 10 list. And thirdly, most importantly, going by the overall scenario, most people prefer to play in a solo match, and that too in a solo first person category. So that was the conclusion. Coming to these data figures, so the overall accuracy was around 91%. And on the testing data set, the precision was coming around 68%, and the recall value was around 42%. Coming to this, some scope and improvement that I could think of was, instead of predicting if the person would be in top 10 or not, instead of that, I could have predicted the actual winning position and also the probability, exact probability of a person winning the match. Also, so there are a lot of bots in the game that are there, which can make, for example, there is a data set in which even if you don't travel any distance, that is 0 kilometers, there were like around 10 killings. So those are like bots or the guys who cheat in a game. So those can be filtered out, and the prediction would be more solid in the nature. So that was the overall idea about the project that I did. Basically predicting if the person would be in top 10 or not. Yeah.
Perfect.
Thank you. Yeah. I hope I'm on time. I didn't. So, any questions, or how should we?
Sorry, I was just trying to unmute myself. Thank you very much, Anshul. That was really interesting. For each of these presentations, let's open up for suggestions or questions from anyone who would like to ask any questions. And I've got a few things too I'd be interested to just follow up. We'll just spend a few minutes doing that for each of the presentations. And so please use the chat window as people are to ask questions.
So this data set is available from the official API on the PUBG website. There's an API documentation. So the question by Rowdy. So the data set was primarily from that API. So this link is also there. I mean, it's easily available on the developers documentation. So yeah. And yes, I do play the game myself, Rowdy.
So one question. I mean, I think you hinted at some of these at the end of your observations, but given your analysis, how might maybe the game manufacturer make use of that analysis to perhaps improve the game?
Okay, it's a great question. So basically coming to the future scope that I already mentioned in terms of identifying the bots and the fake players. So that can be a really using this data set overall, he can observe the pattern in which a person might be using the game in a wrong manner or something like that. So for example, as I already mentioned, before even walking, if somebody is making a killing, so that means there is a bot or some loop in that game in which the feature, so as to how he could make that killing without even moving a distance. So basically identifying those bots and fake players. So that can be one in which a developer can probably make use of this analysis to improve upon the game. And
how certain would you be that they are a bot if they are not walking around?
So basically, if they're not, so bots are basically, there are a couple of things that we can, it's not one feature that can be a deciding factor in which a person is a bot or not. So we have to identify maybe a couple of more features in terms of, like, one is obviously the killing part. Otherwise, other is so we can try to analyze on what average a person walks in a game or swims or drives. If that a bot can obviously walk a lot of distance. So second parameter can be the walking distance or the distance that is traveled within a game, or the number of weapons that are required. So a certain person can acquire a maximum of 76 weapons. So giving those figures, we can have an estimate, and we can not like 100%, but we can somehow with some probability determine that it's a bot. So counting on these variables like these that I already mentioned here.
Yeah, no, that's great. So I understand. I mean, we've done some work with some of the gaming companies too, and being able to identify the cheats is so important to them, because it kind of effectively perturbs the game for everyone else involved. So no, that was a great.
That's an interesting area to explore again altogether. Yeah. So I kind of had one question. So if if I may ask or something like that.
Sure.